so much. I'm Jimmy David. This morning or afternoon, I'm going to be comparing different machine learning models for predicting heart attack. And briefly on, the introduction, a heart attack, also called myocardial infarction, occurs when the blood flow to a part of the heart muscle is blocked. And in 2019, WHO estimated 17.9 million people who died of cardiovascular diseases, and 85% of them were due to heart attack and stroke. And different machine learning models have been used for model classification or regression in medical field, such as SVM for determining the beginning and the end of recessionary time, for cancer survivor, and for real-time forecast. And in this study, I'm going to assess how different machine learning models predict the chance of or the possibility of heart attack. And the goal of this study, like I mentioned, is to classify the target variable using different machine learning models and show the algorithm that is best at predicting the chance of heart attack, and also mention briefly the implication in the medical world. And I have here, I compared 7 different models that I'm not sure I'm going to have time to go deeper into the models. And I compared it based on this output, which is the accuracy, how to score root mean square error, and the confusion matrix. So briefly on data exploration, I have the first 5 rows of my data to be this, and the data was gotten from here, Google assessed in March. And from here, from the data exploration and manipulation, I have the data sets to have 303 rows and 14 features, including the target variable. And I have these 3 CP, talus, and slope to be the 3 features with the most positively correlated features. And I also checked for multicollinearity and removed the resting blood pressure with variance inflation factor of greater than 50. And I normalized using max scalar, and also performed the recursive feature elimination and had the optimal number of features to be 11. And okay, briefly, like I mentioned, the positively correlated features are the ones that are visible brightest, and the deeper ones are negatively correlated features. So, and like I mentioned, I'm not going to go into details of the model description. So I have 7 different models. I can come back to this if I have questions relating to this later. Okay, then moving to my results, I compared all the 7 models based on their accuracy, the percentage of accuracy, the auto score, and the RMSE score. And I have that the ones in red, which is the support vector machine, give the highest accuracy based on the level of the hyperparameter tuning. And then I have the decision tree giving the lowest accuracy, whereas the stacking model improved the accuracy, but still had the same accuracy as the multilayer perceptor. So I also compared based on the confusion matrix. And from here, I hope you can see the confusion matrix. We are expected to have the values only on the main diagonal and 0 on the off diagonal for a perfect model. And on the main diagonal is when the model correctly classifies as not having a heart attack or less chance of heart attack. And the true positive is when model classify as possibility or more chance of heart attack correctly classified. And based on the confusion matrix overall, I have one misclassification as having a high chance of heart attack and misclassifying as low chance of having a heart attack. And I have here 6 misclassified instances of having a heart attack, but the actual there is less chance of heart attack. So overall, SVM had 7 misclassified instances, which was seems to be the lowest among all of the models, and decision tree has more misclassified instances, 15 actually. So, and then multi-layer perceptron and stacking had the same level of misclassified instances. So in terms of the summary, we have the support vector machine performed best with an accuracy of 88.5% and the lowest root mean square error of 0.34, and with 7 misclassified instances from the confusion matrix, whereas the decision tree performed much worse among the models. So in terms of conclusion and implication in the medical world, for early detection and management of heart attack, according to this study and the level of hyperparameter tuning, one would select a SVM model with a higher accuracy. Higher accuracy means that there needs to be more work done on hyperparameter tuning. And also in terms of the data set, we see that based on the recursive feature elimination, some of the features are either not important or being explained by another feature, which then cause multicollinearity, because I have some other features that had variance inflation factor more than 5, but I couldn't reject them or remove them because I will end up removing most of the features. So I want to believe that some of the features are not important or should not be considered when considering heart attack prediction in the medical field. And instead, there should be features, in my opinion, there should be features like race, socioeconomic status, and access to Medicare. I would say the data set is not inclusive. For example, in the United States, and CDC reported last year that the highest number of chronic disease were among Black men. And I think an unbiased data should take this into consideration. And also for future work, we also need to consider more other powerful models like neural network and deep learning models. And I think I'll stop here. Thank you.